Hello everyone, today I will discuss assignment week 8 to week 11 for the course Fuzzy Set Logic for the final examination point of view. And in this assignment just I will cover the fundamental concepts. So in week 8 we are given with two fuzzy set A and fuzzy set B. And for fuzzy relation matrix R between A and B, so first of all we have to find out the relationship between fuzzy set A and fuzzy set B. So this is very common, and you can evaluate or calculate fuzzy relation between set A and B. After that, what you have to do, so this is the fuzzy set A and this is the fuzzy set, this is the complement of this one. So just we have to take the complement of this one, 0.1 complement 0.9, 0.1 complement again 0.9, 0.2 complement 0.8. So just we are going to complement these fuzzy set R. So fuzzy set R, and this is the complement of fuzzy set R. So in this way, now in the next uh, in this assignment there are different operations are being asked. So question 1, diagonal matrix of R. So diagonal matrix of R, this will be the diagonal matrix of R, right? Diagonal matrix of R bar, that is R complement. So this is the diagonal, right? So these are the answers directly. In next question, diagonal matrix R intersection R bar, right? So this is the diagonal matrix of R and this is the diagonal matrix of R complement. So we have to take the intersection. We have to take the intersection. In intersection we know we have to take the minimum of them, 0.1, 0.9. So minimum is 0.1, 0.1, right? So 0.5, 0.5. So minimum is 0.5 because both are same. And in the last case 1.0 and 0.0. So minimum is 0. So we have to consider 0.0. So final answer will be 0.1, 0.5 and 0. So this will be our final answer. So in this way we can calculate all the remaining 10 questions. Just we have to take care which operation is being asked, like R union R bar. In third question R intersection R bar. In fourth question R union R bar. But in case of union we have to take the maximum of them, 0.1, 0.9. So maximum is 0.9, so 0.9. So I don't think so that I have to explain all these things to you. 0.5, 0.5. So again maximum value will be equal to out of this zero point 0.5. And in the last step 1.0 and 0.0. So maximum is 1. So this 1.0. So in this way we can calculate all these 10 questions. So final answer will be like this. And we have to be very cautious, very alert during solving this question, because it may be a small mistake may to occur, and after that result will be wrong. So in this way we can evaluate all the other 6 questions. Just we have to follow the these types of operations. Fuzzy set logic assignment 9, that is week 9. So what is the fundamental concept? We are given a fuzzy set A with the universe of discourse. For continuous it is given as, and for discrete it is given as. Now we are having 4 formulas. So the membership value for the linguistic term vary or true. If this will be available, then we have to square off that particular membership value. If the linguistic term is more or less, in that case we have to take the square root of this particular value, right? And in next, very bright, so it means in this particular case very bright, very is used 2 times. So in this case we have to multiply membership value 4 times, right? And very it means 3 times it is used, or we can say 2 raised to the power 3, that is 8 times. So in this case we have to multiply membership value 8 times, right? So in this case, very it is used 2 times. That's why we have to multiply membership value 2 raised to the power, that is 2, that is 4 times, right? So we have to calculate this one. In this case, membership very use is 3 times. So this is the basic concept. So this is the universe of discourse which is given to us, and this is the uh, membership this is the fuzzy set which is represented by heavy. So what will be the membership function value of very heavy? So we have to square of that particular membership value at generic variable value 3. So it is specified for generic variable 3. So generic variable 3 in this case is equal to this one. So for this case, membership value is 0.5. So 0.5, and the term is used very heavy. So in case of very high, we have to square of this one. When we will square of this, the result will be equal to 0.25. 0.25. So this is the only concept just we have to use. In the next question, very heavy, very heavy, that is 2 raised to the power 2. 4 times we have to multiply the membership value, right? And for which generic variable? At generic variable value of 6. So 6 in this particular case is 0.9. So multiply 0.9, right? And 0.9. So final answer will be equal to 0.6561. So in this way we can evaluate this particular assignment. Question number 9, fundamental concept. In the same assignment, there are another two formulas are there. So we have to calculate the concentration and dilation. For concentration, we have to take care that value of K generally will be considered as K is equal to 2. So in this case, we have to square that particular membership value in the case of concentration. So question will be like this: let A is a fuzzy set defined over the universe of discourse, X is equal to 1, 2, 3, 4, and this is the fuzzy set. So 0.2, 0.4, 1 and 5. What will be concentration of A? Just we have to square of that particular membership value, because in case of concentration, value of K is equal to 2. So K is equal to 2. So we have to just square of that particular membership value. 0.2 square is equal to 0.04, right? And 0.4 square is equal to 0.16. 1 square is equal to 1, and again 0.5 square is equal to 0.25. So this will be the correct answer, right? For question 10, there is another term, dilation. In case of dilation, we have to consider value of K is equal to 0.5. When K is equal to 0.5, it means we have to take the square root of that particular membership value. So this is the question. 0.2, same question, but right now we have to calculate the dilation. For K, for the dilation, value of K is equal to 0.5, that is 1 by 2. 1 by 2. So we have to take the square root of that particular membership value. So 0.2 square root will be equal to 0.447. 0.4 square root is equal to 0.6332. 1 square root is equal to 1. 0.5 square root is equal to this one. So this will be the correct answer. So this is the overall story of the week 9. For week 10, the fundamental concept is this one. So it is very important, contrast intensification, right? So question 1 to 4 are of similar type. For continuous variable, formula is equal to this one. For discrete, this one. Now in this case, value of membership is very important, right? So when value lies between 0 and 0.5, then we have to take the we have to consider this particular formula. But when value lies between 0.5 and 1, we have to consider this one. We have to consider this one. So in this, one important thing is that when the value lies between 0.5 and 1, the contrast intensification for new value will be increased, and when lies between 0 and 0.5, then it will be decreased. But when its value will be 0.5 or 1, then for the new set, the value will remain the same. Like, so this is very important concept. The contrast intensifier int increases the value of mu a x which are above 0.5, right? When the value of membership value above 0.5, then value will be increased, and diminish means decreases those which are below this point, right? But in the case when value will be 0.5 and 1, then it will be same. So this is the question. Let fuzzy set A defined in the universe of discourse, this one, x is equal to 1 2 3 4, right? And this is the fuzzy set given. So what will be the membership function value at generic variable 2, at generic variable 2 for the fuzzy set obtained by INTA, intensification A? So this is the formula, and in the formula we have to evaluate that's 0.1 less than 0.5, 0.3 less than 5, and 1 and 0.5. In both these two cases this formula will be applicable, right? And 1 and 0.5, in both the cases this formula will be applicable, right? So this is the fuzzy set A, this is fuzzy set A for x is equal to 1 2 3 4, and these are the element x1 is equal to 1 2 3 4, mu a1 is equal to 0.1, mu a is equal to 0.3, and so on. So just we have to evaluate 2a raised to the power 2, 2a raised to the power 2. So 0.1 multiply by 0.1, that is 0.01, and multiply by 2, that is 0.02, right? So 0.3, how we evaluate this? 2a square, it means 2 multiply a square. A square means membership of that particular value is 0.3, so 0.3, 0.3 multiply 0.3, so this will be equal to 0.3. So in this way we will evaluate this one. So this comes out to be equal to 0.18, 0.18. So now membership value is greater than 0.5, 1 and 5, when it will be equal to 1. So formula will be equal to, this is the A1, we can say negation or we can say complement, negation 2 negation A square. So how it can be represented? Just more be specific. Negation bracket start 2 multiply and negation of 1, right? So in this case it is 1, it is 1. So negation of 1 means 1 minus 1, 1 minus 1, it will be 0, and it will be 0. 2 multiply by 0, that is 0, and 2 multiply by 0, 0, and negation of 0, negation of 0, again it will be 1 minus 0, 1 minus 0, that is 1, right? So for this case 0.5 negation to this, again negation of 0.5, negation of 0.5 means this one. So negation of 0.5, 1 minus this one, right? So 1 minus 0.5, again 0.5, 0.5, 0.5, and square of 0.5, that will be equal to 0.25. Square of this will be equal to 0.25, 0.25, and again we have to multiply by it 2. So 2 into 0.25, again it is 0.5, 0.25. After that we have to take negation. So negation 0.5, 1 minus 0.5, again this. So I already told you for the case of 1 and when value 0.5, then new value will be equal to exactly same, right? So again this will be the same. But when value lies between 0.5, the new value will be decreased, and when value above 0.5, new value will be decreased. In this case, value is 0.1. So new value becomes less than this one, that is 0.02. In this case value is 0.3 because it is less than 0.5. So new value becomes 0.18, which is less than 0.3. So in this way we can calculate all these parameters. So we have to be very specific for this particular formula. So orthogonality concept 5 to 8 are of similar type. In orthogonality, all the membership value must, when we are going to sum, its value must be equal to 1. So we are given fuzzy set A, fuzzy set B. Now what will be the membership function value at generic variable 2 for the fuzzy set C? So we have to create a fuzzy set C. So this is a fuzzy set A, fuzzy set B, which is given to us. So value is equal to 1, 2, but in fuzzy set it is 3 and 4. So we have to complete fuzzy set A, 1, 2. For element 3, membership value will equal to 0. And for element 4, membership value will equal to 0. In fuzzy set B, 3 and 4, 3 and 4, right? Again we have to complete it with the help of this. But in both the cases, for fuzzy element 1 and 2, membership value equal to 0. Now we had to calculate third fuzzy set C. So how we evaluate? We have to consider column wise. For fuzzy element 1, what will be the membership value? We have to add all these, and sum must be equal to 1. So 0.5 plus 0, that is 0.5. So remaining value will be equal to 0.5. In this case, 1 plus 0, already it is 1, so next it will be considered as 0. In this particular case, membership value 0 plus 1, already 1, so definitely it will be equal to 0. In the last case, 0 plus 0.8, 0 plus 0.8, and this must be equal to 1 in case of orthogonality. So how much we have to add? We have to add 0.2. So 0.2 will be considered as the fuzzy membership value for element 4 for fuzzy set C, right? So in this way we have to evaluate this, right? Now we can evaluate any type of questions. Fuzzy set logic and system and application, week 11 concept. So let us consider the Mamdani fuzzy model as a rule. If x is A and y is B, then z is C. In this case, only one rule is given, right? Rule. So in the option multiple rule, both these option will be removed. Like now, single rule. Now we have to calculate whether it is single antecedent or multiple antecedent. If x is A and y is B, it means there are multiple antecedent. Only if the question will be like this: if x is A, then z is C, then it will be single rule, single antecedent. But in this case, if x is A and y is B, so therefore it is the case of multiple antecedent. There is only single rule but with multiple antecedent. Now question number 3, rule 1, rule 2. So directly in this question it is given rule 2, that is multiple rule. So therefore option B and C are out of race. Now we have to calculate whether it is single antecedent or multiple antecedent. If x is A1 and y is B1, again it is a case of multiple antecedent. Therefore multiple rule with multiple antecedents. So in this way we can calculate. And one more important thing, if the aggregated output of the Mamdani fuzzy model of the trapezoidal, so trapezoidal functions will be given like this. So I draw this trapezoidal function 1, 3, 5 and 6. So membership value at 3 is equal to 1, that is highest. At membership value at 5 it is 1. So with maximum membership value, what will be the defuzzified crisp output using the mean of maxima? So in this question, largest of maxima, one type of defuzzification, smallest of maxima, and mean of maxima, mean of maxima. So in case of largest of maxima, means this is the value 5 which is highest, and at this membership value is equal to 1. So largest of maxima equal to 5. Smallest of maxima, this is the smallest value where the membership value is high, that is 1. So smallest of maxima is equal to 3. Mean of maxima, so directly we have to just average of these two value, 3 plus 5 divided by 2, right? So answer will be 4. Just we have to enclose in bracket. So in this way we calculate this defuzzified value. So thank you so much. Now I will post videos on Mamdani model, Larsen model and TSK model. today itself, and after that daily I will upload one videos, and one video will consist up to 10 videos which are given to us, and just I will describe only the important concept, and it may be possible some videos are not so important and I will skip them. I will highlight which videos are not important. So thank you so much.